XR studies investigate interaction, perception, and user behavior in immersive environments. But turning an XR study idea into a runnable prototype is difficult. Researchers often need to review related work, define a study plan, search for 3D assets, build scenes in Unity, and implement interaction logic in code. These steps are rarely linear. Researchers often move back and forth across tools and representations through multiple rounds of iteration. To ground this problem in real XR research practice, we conducted a formative study with 6 XR researchers. Based on these findings, we derived a set of design considerations and organized OrchestrXR around 3 design strategies. Guided by these strategies, we present OrchestrXR. It organizes authoring into 3 connected stages: study design, scene generation, and interaction generation, to transform an initial idea into an early-stage XR study prototype in Unity. Here, we show an example workflow in OrchestrXR. The user begins by sending an XR study idea through the chat box. In the study design stage, OrchestrXR first grounds the idea into a refined concept, a possible title, and a research question. After the user confirms this direction, the system retrieves related XR papers that the user can inspect to further refine the idea. Once the idea is ready, the user proceeds to study planning. If needed, the agent asks follow-up questions to clarify unclear parts of the study. OrchestrXR generates a structured study plan that includes the research goal, task flow, conditions, and scene and interaction requirements. The user can then inspect the plan, revise it through the chat interface, and confirm it when satisfied. The workflow then moves to scene generation. Here, the user reviews a scene specification and can edit scene elements such as object position, size, and style through the scene graph. After the user confirms the scene design, the system generates executable construction steps for review. The user can still revise these steps before execution, for example, by removing an unnecessary ground plane construction step. Once confirmed, the agent incrementally executes the scene plan in Unity. The plan steps and execution progress are visualized so the user can inspect how the scene is being built. If something looks wrong, the user can select objects from the streamed Unity scene and hierarchy, add them to the chat context, and ask the agent to patch the scene. Next, the workflow enters interaction generation. The user first reviews an interaction specification and can edit script-related nodes and their public parameters. After confirmation, the system enters execution, which includes both code generation and assembly. Throughout this process, the generated code, execution state, and verification steps are all exposed to the user. Finally, the user can play the prototype in Unity. If issues remain, such as an unclear interaction flow or an incorrect UI canvas, the user can continue working with the interaction agent to patch the prototype. In the end, OrchestrXR produces a runnable early-stage XR study prototype that follows the user's intent. It also supports runtime logging such as condition and timing data. We evaluated OrchestrXR through a user study with 12 XR researchers. Participants completed 2 assigned task cases across 4 representative XR study authoring scenarios, followed by an open-ended session using their own ideas. Here we show several example prototypes from the study, illustrating how participants used OrchestrXR to author diverse XR scenarios through its staged workflow. Overall, the results suggest that OrchestrXR effectively supports early-stage XR study authoring by helping researchers turn abstract ideas into inspectable, runnable prototypes under user control.